So yesterday we talked about how to write formulas for ionic compounds. Today we're going to go the other direction. So we're writing the names off of the formulas. And we have one page of kind of steps or rules to how to do this. And then we have lots of practice to do. And we have a practice worksheet for you afterwards. Rule number 1. The cation is always named first. That's the one that has the positive charge. That's the one that's the metal. And to name the cation, you just write down the name of the element. So that part is pretty simple. If it's a transition metal, or lead or tin, then you use the formula, kind of like working backwards from what we did yesterday, to find out what its charge is. You have to write down that charge as a Roman numeral in the middle of the name. You will need to know your Roman numerals through about 6 or so, definitely not higher than 10. Then we have to name the anion. The anion is the negative one. The anion is the nonmetal. If the anion is monatomic, meaning there's one type of atom there, you change the ending of the element name to IDE. So sulfur becomes sulfide. Chlorine becomes chloride. Fluorine becomes fluoride, and so on. If the anion is a polyatomic, then you just have to look up the name from the chart. Make sure you spell it right, and make sure I can read your handwriting. Because as you saw yesterday, some of those names are very similar. Yesterday we had an example with a sulfite, which was right next to sulfate on the list. And one letter can make the difference of whether or not you get the name right or wrong. Remember from yesterday that compounds with polyatomics are called ternary compounds. Your practice worksheet is set up again kind of like yesterday's, where it has binary compounds on one side and ternary compounds on the other. So now we just have practice to do. Let's see if we can name some compounds. Name the cation first, and it's the name of the element. So what's the cation? Calcium. And then the anion, is this monatomic or polyatomic? Monatomic. So we look up the element name, that's fluorine, and change it to fluoride. So this is calcium fluoride. Another one that's very similar. Name the cation first. Just look up the element, and that is lithium. Name the anion second. Sulfide. Lithium sulfide. What's different about this next one? It's a transition metal, so we're going to have to do a little bit more work on this one. We still name the cation. What is the transition metal? Iron. We're still going to name the anion at the end. That'll be chloride. And we need a Roman numeral in the middle. Here's where you have to kind of think backwards of what we did yesterday. We need to find out what charge that iron has right now. To figure out what charge the iron has, you look at what it's paired with. It's paired with chlorine. What charge does chlorine have? Look where it is. It's negative. It's at the very end. Each chlorine is what charge? -1. And if we have 2 of them, then that totals up to -2. If we have a -2 on the chlorine side, what do we have to have on the iron side? +2. There's only one iron atom there, so its charge has to be +2. That's kind of the reverse reasoning process. You can reverse crisscross most of the time, in which case that little 2 next to the chlorine would go back up to the iron, and you know the iron is +2. That doesn't always work though. If you have reduced before you wrote your formula, remember the third part was crisscross and reduce, then that little trick is not going to work for you. So you always want to think about what is the negative side total, what's the positive side total have to be. Try this one. One small difference here between this one and the last one. What would the charge be on the iron this time? 3. 3, because it still has to balance out the 3 chlorines. So this one is iron 3 chloride. More practice. What's the cation name?
Isn't it T between those?
Yeah, what's PT? Platinum. Platinum's a transition metal, so that means we need to figure out what its charge is. To do that, we have to look at what it's paired with. What is the charge on each of the oxygens? -2. -2 times 2 is -4. So what's the charge on the platinum have to be? +4. So platinum 4 oxide. What would this one's name be? Copper 1. It's the end of it. Bromide. The copper has to be +1 because the bromide is -1. This one is maybe just a little bit harder. What is nitrogen's charge? -3. Times 2 makes -6. That means we have to have a +6 on the other side. But how many zinc atoms are there to divide it among? 3. So +6 divided by 3 makes each of them +2. So this is zinc 2 nitride. And I put a little note next to this one. Zinc is almost always +2. So if it doesn't state otherwise, you can assume that it is +2. This one is similar. What's the charge on the phosphorus? -3 times 2 makes -6. That has to be balanced with a +6. +6 divided by 3 tin atoms makes each one 2. So tin 2 phosphide. Let's do some ternary ones. These are the ones with the polyatomics, so you will need to look up stuff in your chart. You start the process exactly the same. What's the name of the cation? Calcium. Do you know this anion yet, or do you need to look it up? It is hydroxide. Calcium hydroxide. See if you can find this one in the chart. Thiocyanate. Sodium thiocyanate. What's this one? Aluminum. Should be chromate, not to be confused with dichromate. This one would be magnesium nitrite. Again, watch your spelling on that. Nitrite and nitrate are not the same thing. This one's a little bit different. Where's the polyatomic this time? In the front. Ammonium chloride. Let's see if we can do this one. This kind of puts all of our rules together. What's AU? Gold. What's CO3? Carbonate. What's carbonate's charge? -2 times 3 of them makes -6, which means we have to have a +6. +6 divided by 2 gold atoms means each gold atom has to be a +3. Gold is a transition metal, so you need gold 3 carbonate. one should be lead 4 cyanide. One more. Last one should be iron 3 phosphate. Questions? Okay, we are all finished for today.